What's up, everyone? This is Dr. Jax. Today we're going to look at lenses and how we can use a laser to establish the focal point. What the focal point means is where the light rays will all converge at a single point. In the case of a convex lens, it's what we call a converging lens. So as the light passes through the lens, it will bend and converge, whether it's above or below the principal axis. So what you're going to see first is where I'm going to let it play at full speed, and you'll see as the laser moves above and below, you'll see how the light bends. After that, we'll do a ray drop diagram to show how the light actually would converge if we were looking at individual beams of light using the laser. So let's look at it in full speed. As you can see, when it's above, the light bends down, and when it's below, the light bends up. So now what we're going to do is trace a ray at the midpoint as well as above and below the principal axis to show that they will all converge at a single point on the other side of the lens. So if you look, if the light forms a 90-degree angle perpendicular to the surface, you'll see that the light passes straight through. So if we were to draw a ray diagram, you would see the light passing straight through as shown here. However, when the light begins to move up and down, then you will see it bend. In this case, you can see how it starts at this angle, heading straight into the lens. So as you can see, it bends through and crosses our original line. When we jump down below and trace the rays, you'll see a similar effect, but this time it bends up. The idea of the focal point is that after all the lights bend and pass through, that they all converge at a single point, which we call the focal point. And so this point right here represents the focal point. If we were looking at focal length, it would be the length from here to the center of the lens. So now that was a convex lens, which we call a converging lens. However, we also have concave lenses, which we call diverging. And what you'll see here is as the light passes through, the light rays bend away from each other and do not converge on the other side of the lens. As such, we have to trace them backwards, and so the focal point will actually be on this side of the lens. So let's look at it at full speed, and then I'll show you the ray drop diagrams to show how we can figure out the focal point. Okay, so now what I'll do is I'll again leave one line as it's passing straight through the lens, and then I'll look at what happens to the light above and below the principal axis. Okay, so as you can see here, as the light rays pass through, they diverge on this side. However, if you were to trace the light rays backward, you can see how they all converge on this side of the lens. So for this, we would find the focal point on this side of the lens, and we would call this an imaginary image being formed because the light actually does not converge to form at one particular point.